Okay, welcome to the Haybridge Maths Department video production on Core Pure Mathematics Book 2. We're going to begin with Chapter 2 now. Chapter 2 is entitled Series. So, you've already met the idea of finding the series, the sum of the series using standard results from in year 1. For example, you might have been asked to find the value of or the expression first and then evaluate it. So express in terms of n the following sum, and then you use the standard result for the sum of r, so it was a half n times n plus 1, and then a half of r squared. These are in the formula booklet: 1, 6, n plus 1, and then 2n plus 1. And the sum of n natural numbers is not in the formula booklet, but the sum of the squares and the cubes is. Now this time we're going to use what's called the method of differences. Okay, the method of differences involves applying a trick which involves expressing the sum that we are dealing with in a way that allows lots of terms to be systematically cancelled, and you'll get a nice simplified expression. The first step will always be finding an alternative way of expressing the this part, which is the nth term, in an alternative way, which will involve the difference between the two terms, otherwise it will not be cancelled. So the best thing to do is to actually have a go at doing example 1. You will also need to learn, that will come up in example 2, how to split a fraction into partial fractions. Beginning example 1, we've got to show that 4r cubed is equivalent to the right hand side. Here it is. So it's just algebraic manipulation. It's always a good idea to start with the side that you can do something to. So we're going to start with the right hand side. On the right hand side we've got r squared. I always rewrite it as it appears and then manipulate it. So here, once we've rewritten, we just need to expand those brackets. So it's r squared plus 2r plus 1 in the first bracket minus, here I'm going to put r squared at the front, and then r squared minus 2r plus 1, the second bracket, expanded, or you could factorize r squared and then tidy up the whatever is in the brackets, but I'll expand it. R to the power 4 plus 2r cubed plus r squared minus r to the power 4 minus 2r cubed plus r squared. So you've got r squared plus 2r cubed plus r squared minus r to the power 4 plus 2r cubed minus r squared. And hopefully, this was to the power 4. That will nicely cancel. The r squared cancel, and you're left with 4r cubed, which is the left hand side as required. Okay, so how does the method of differences work? So the first thing, you will in part A, you've shown that 4r cubed can be replaced with this identity. So with the right hand side, we are dealing with 1r cubed. So we've got a quarter of this, so we just need to divide that by 4. So a quarter of this is equivalent to r cubed. So the first thing we're going to do, we're going to rewrite our sum in terms of our new expression. So it's the same as a quarter, r squared, r plus 1 squared, minus r minus 1 squared, r squared. I'll bring the quarter outside, and let's just rewrite it so you could see what it looks like. Leave it as it is, and it's r squared times r plus 1 squared minus r minus 1 squared, r squared. Okay, and then you're going to write this sum in the expanded form, as if you were evaluating all the terms from the first to the nth one. But obviously we don't know how many terms there are, so we are going to write the first 3 terms and maybe the last 2. Sometimes the first 2 is enough, but just to show you what it looks like, we're going to find it. And the way to do it, we are going to find the first term first and write it on the first line. So the first term is found by substituting instead of r, 1. Okay, so this is equal to a quarter, and we'll open brackets and write the first term plus the second term plus the third term, and then we'll have the last 2 terms. So the first term you evaluate by putting 1 into this expression. So it's 1 squared, and then multiplied by 2 squared, minus, if you put 1 into that, always write it down even though it's 0, 0 squared, times, if you put 1 into that, that's 1 squared. And the next term is going to be found when you substitute 2 instead of r. So here we've got 2 squared, multiply, if you do 2 add 1 is 3, so that's 3 squared. Here we're going to have 2 minus 1, so it's 1 squared times 2 squared. I'll just do one more term from the top. When r is equal to 3, so do consecutive terms. So the third term, you're going to put 3 squared. You can actually spot here the pattern, so it should be 4 squared. Check whether that's right. This one should go to 2 squared, and this one should go to 3 squared. And then you'll have all the terms all the way to the last term. Now I normally leave a space for the term before the last term and write the last term first because it's easier for me, but the idea is to find the last term, which is the nth term, and the one before, which is n minus 1. So let's write this expression. Instead of r, we are substituting n. So it's n squared, n plus 1 squared, minus n minus 1 squared times n squared. And the term before, we're going to substitute 1 less than n instead of r, so it's n minus 1 squared. Then you will have n minus 1 plus 1, so it's n squared. Then you will have n minus 2, 1 less than the previous term, or the last one here, and this is n minus 1 squared. There you go. And like I mentioned before, the idea is to find a pattern of terms that can be cancelled. So you're looking for the same terms. You don't need to evaluate them. You should notice that you've got 1 squared times 2 squared and 1 squared times 2 squared here. So one has a plus and one has a minus. If you add them together, they will go to 0. This one has a brother over here, so let's cancel them. Now this one here would have cancelled with a term over here, but the one over here would have had a term to cancel with this. So you can just diagonally cancel it like that, and these nicely. Oh, brilliant. So if you see, what are you left with? We are going to put it together. So you'll have a quarter, and you'll have minus 0, because 0 times 1 is 0, and then plus n squared times n plus 1 squared. So it's it's going to be a quarter n squared times n plus 1 squared. So it's proven. There you go. Okay, we're going to move on to example 2. So this time it asks you first of all to verify that this identity, so the left hand side is equal to those two fractions subtracted, and hence find by the method of differences what this sum is equal to in terms of n. Okay, so verify simply means that you just need to maybe add those two together and show that they come to this fraction. So, but I'll show you also how else to do it if you were asked to prove that this is equal to that. Okay, so to verify, you start with the right hand side, because you can do something to this a lot quicker. So we're going to add them together, bringing to the common denominator. So this one will multiply by r plus 1, and the second fraction by r. So you will have r times r plus 1 in the denominator. You've got 1 times r plus 1 minus 1. 1 and minus 1 will cancel. You are left with minus r, pardon. R and minus r will cancel. You're left with 1. R times r plus 1 as asked. So this is the left hand side. Okay, now we're going to use the method of differences. Oh no, we'll do that in a moment. Let's have a look at what to do if you've been asked to prove it. Okay, so you're going to use the method of partial fractions. I mean, usually it will ask you to prove it to express it in terms of partial fractions, or it would be written as show that this is equal to a over r minus b over r plus 1, and you could use partial fraction method, or perhaps another method if you prefer, by comparing coefficients. But partial fraction method you need to know. You will learn it halfway through year 2 of the normal maths course, so we might as well learn it right now because you will find it very useful. So what you do, you are going to start with the left hand side, and you need to realize that if you've got two factors in the denominator, then this fraction can be split into two fractions, 1 over r and 1 over r plus 1. We always put a plus here, and we write a on the top of the first fraction and b on the top of the second fraction. So now we just need to bring this to the common denominator, so I'll just write it here. So multiply that one by r plus 1 and this one by br. Do not expand these, and that by r plus 1. Now for these two to be equal to each other, the denominators are the same, so the numerator must be equal to 1. So 1 is a times r plus 1 plus br. And here we just need to find what a and b are, and the quick way of doing it is by substituting the convenient value of r, because it's an identity. Identity works for all values of r. It's allowed for a question, so it's any value. So if I choose convenient value to eliminate one part, then you'll be able to work out the other. So the best way to do it is to make this bracket equal to 0, so that will be equal to 0 when r is equal to minus 1. So it's 1 is equal to a minus 1 plus 1 is 0. That disappears. That's what I wanted to happen. And b times minus 1. So that gives me b is equal to minus 1. The second factor to disappear is this one, and it will happen when we make it equal to 0, so you could substitute r equals 0. So if I put 0 into wherever r is, you'll have a times 1, so you'll be left with a, and b goes to 0. So a is equal to 1, and here is your value of a and b. Okay, so let's get another piece of paper and have a little evaluation of the sum. So now we've learned how to split our fraction into two partial fractions. We've got 1 over r minus 1 over r plus 1. So usually I should have copied the original question, but I've copied it with my nth term being replaced, or rth term replaced with the equivalent. Okay, so we are going to just find the values of first, second, third term, and the last but one. So it's r is equal to 1, and then r is equal to 2, r is equal to 3, and then r is equal to n, and then 1 before n minus 1. So the first term you're going to get by putting r equals 1. So write it long way, don't need to evaluate it unless you do got 1 plus 1, which is 2, it might be easier. So the first term is 1 over 1 minus 1 over 2. If I put 2 into this, so the second term will give me 1 over 2 minus 1 over 3. The third term is going to give me 1 over 3 minus 1 over 4. You can see the pattern there. And then you have all the terms all the way to, and I will write, before I write n minus 1, I'll write 1 over n minus 1 over n plus 1, and then 1 over n minus 1. I mean, this is easy, so you could just put n minus 1 first, it doesn't matter. And I know from experience that students, if they start with this one, sometimes they mess it up on more complicated expressions. But if you're confident, you just don't do those. Let's find a matching pair. There you go. Now minus a quarter here would have had a pair here, but 1 over n minus 1 would have had a pair here, so you just cross them off together, and these two will cancel. All the ones in between would have nicely cancelled, and you're left with 1 over 1 minus 1, so which is 1 minus 1 over n plus 1. Normally you'll be asked to, or it will be expected from you to gather these two together. So it's 1 over 1, you multiply that by n plus 1. There you go, so we've got n plus 1 minus 1 over n plus 1, which is n over n plus 1. That concludes example 2. We will move on to example 3, but since there are 2 more examples before the exercise, I'll split this video into 2 videos. So go on to the next video for example 3 and 4. Hello again. Right, we've got example 3. Find the sum of 1 over 4 r squared minus 1 of n terms. So by method of differences. So your job here is to express it in terms of the difference of 2 fractions. This is partial fraction, so you've got to have a little you need to do a little bit of work on this algebraic manipulation to find 2 fractions. So factorize the denominator. Okay, and you notice there are 2 factors in the denominator, so that tells me that I'm going to split it into partial fractions. So I'm looking for 2 fractions, one with a denominator of 2r minus 1, and the other with the denominator of 2r plus 1, that when added together give me this fraction. So this is how you do it. So the idea is you can actually get straight away to the numerators by imagining multiplying the top, the right hand side through by the denominator, if you prefer. So if you multiply the first fraction by 2r minus 1 and 2r plus 1, so imagine you'll be left with 1. The 2, let me just write it down here so you could see it maybe. You don't need to write it down as long as you understand what I'm doing. Then these two would cancel. So you'll be left with a times 2r plus 1. So imagine multiplying it through. This one needs to be given the other denominator. And b, if you multiply that through by this, then these two will cancel, you but left with 2r minus 1. Otherwise, you do the join it together as we did in the previous example by finding the common denominator, so multiplying the two factors in the denominator and then combining them. So what we're going to do, we are going to use the same method as before. We are going to substitute the value that make this bracket disappear, so you can just make that whole thing equal to 0, the first one, and you'll be able to find what b is. And then make this one bracket disappear, substitute, that will go to 0, and you'll be working with this. So the value that makes this bracket disappear is minus a half. So left with 1 equals, clearly that will go to 0, and this one will go to minus 2. So let me just write it down. So it's 2 times minus a half minus 1, in case you want to do it in the on the calculator because you're not feeling confident. So 1 is equal to minus 2b. That gives me b is equal to minus a half. Let's move on to the second fraction. To make that equal to 0, you would need to substitute a half. So a half into this one, I'll do this one quicker, that gives you 2a. Therefore, a is equal to a half. So you've got a way of rewriting our sum in terms of the difference of two fractions, because one is negative, one is positive. So our fraction, our nth term, can be written as the sum of, or the difference of, so let's have a look. Both are a half. So to write a half, I mean, it looks a bit awkward if you put it in the numerator. So the way to write it is to drop the 2 into the denominator. Alternatively, you could just factorize a half out and then write 1 and minus 1. But whatever is your preference. Right, so here we've got those two expressions. We're going to substitute r equals 1, r equal 2, r equal 3, and then we're going to write r equals n and r equals to n minus 1. So this is just a reminder which term in the series I'm evaluating. So you're going to get a 1 over 2. Now if I substitute 1 into this, you have 2 times 1 minus 1. That gives me 1. If I put 1 into this one, right, let's just correct it. That was 2r plus 1. So if I put a 1 into this one, I'll have 2. And then it's going to be 2 plus 1, which is 3. Okay, let's go to the second one. What happens if I put 2? I still have a 2 there. You have 2 times 2, which is 4 minus 1, which is 3. And over here, I'm going to get 2 times 2, which is 4, plus 1, which is 5. And let's just, for good measure, I could not already see that these two will be the same, but let's just do this next one. So it's 6 minus 1, which is 5. And then this one gives you 3, which is 7. There you go. The last term is going to be 1 over 2 times 2n minus 1 minus and 2n plus 1. And if you notice those 1, 3, 5, these are odd numbers, so they jump every 2. So I need to have 2 more less over here. So it's 1, 2, 2 and minus 3. But if you are not feeling confident, there's nothing stopping you from doing it slowly. So 2 times n minus 1, and then that would be 1 over 2 times 2n minus 2 minus 1, which is minus 3. And this one, 2 less than that, will take it to 2n minus 1. There you go. Okay, so let's just find the matching pairs. Like I said, I've already spotted these and these two are brothers. So are these. This here would have a brother here, but this one would have a brother here. So let's just cross them off at the same time. And then you're left with these 2 fractions at the end, 1 fraction at the end and 1 at the start. So altogether, let me just do it in reds. So we are left with 1 over 2 times 1 minus 1 over 2 times 2n plus 1. You just need to bring it into the common denominator, so this one needs to be multiplied by 2n plus 1. And you have 2n plus 1, one of them on the top, and then minus 1. So 1 and minus 1 will cancel. You have 2n over 2, 2n plus 1, and these 2 cancel as well. I'll just write it here. N over 2n plus 1 is our final result. Great. This was example 3, and there's one more example. Let's move on. It's example 4. Brilliant. So to begin with, let's just see the wording. We've been asked specifically to split it into partial fractions. This simply means, I'll just show you exactly, just check that you can see it very well. Okay, so 2 over r plus 1 and r plus 3 can be split into a over r plus 1 plus b over r plus 3. Always put a plus, because that minus, just where you work out b, it will be a negative number. So otherwise it will become too confusing. So always write the plus to begin with, although we know it will be a minus eventually. But you don't know whether between these two might be this negative, this positive. So depending how you decide to split it. Let's have a look. So imagine multiplying it through by r plus 1, r plus 3. You'll be left with the numerators only. You've got 2, and a will be multiplied by r plus 3, and b will be multiplied by r plus 1. And we're going to quickly find the values of a. So substitute minus 3, because that's what makes the first bracket disappear. You've got 2 is equal, that will be 0, and this one here is going to be minus 2b. So b is equal to minus 1. And let's put r is equal to minus 1 as our second value to make the second bracket disappear. So it's minus 1 will make that go away. You will have 2a is equal to 2. So a is equal to 1. Perfect. There you go. So that's the fractions will be 1 over r plus 1 minus 1 over r plus 3. So we're going to move on to part B, where it says hence prove the following result. So it just tells you, using the method of differences, it was specific with that. So let's start with the left hand side. We're going to, this time I will copy the term, the nth term fully, or the rth term, because it's in terms of r. There you go. Split it now into the equivalent expression. So it's 1 over r plus 1 minus 1 over r plus 3. And then the next stage is exactly the same as before. You're going to put r equals 1, r equals 2, r equals 3. We'll do r equals n, r equals n minus 1. Let's just find the sum expanded. So the sum of all nth terms is equivalent to the first term. The first term is 1 over 2 minus 1 over 4, plus the second term, which is 1 over 3 minus 1 over 5. Notice there's no brothers that cancel, so it's a good job we've gone up to the third one. If you don't find the brothers, any pattern, you need to carry on and do more terms than we normally do, but this one we normally do 3 anyway. So it's 1 over 4 minus 1 over 6, but that's enough because I could see these two are nicely matched up. Then you've got all the ones here, and then you've got 1 over n minus 1 plus 1, that will give me n, and then 1 over n plus 2. And the last term is 1 over n plus 1 minus 1 over n plus 3. Now this might be enough, but notice there's no brothers that cancel. So just to be certain, let's just go one more before that. So if I put n minus 1 here and minus 1 over n plus 1, if you substitute n minus 1. And then here you could see these two cancel nicely, so it's just helpful to see that. Okay, so let's find a matching pair. So minus a quarter goes nicely with positive a quarter, cancel it. Minus 1/5 would have had a brother over here, but this term would have had the brother, you know, 2 terms before it, so that you can cancel it together. Minus 1/6 would have had a brother 2 terms below this one, and this one would be over here, so you can cancel that, and these two cancel. So you're left with 1 over 2 plus, so half, let's write it here, plus a third, minus 1 over n plus 2, minus 1 over n plus 3. Right, add these two together, you can do them on the calculator, that will give me 6 on the bottom, 5, 3 plus 2. So we're going to bring them into common denominator, so multiply. The common denominator is simply all the denominators multiplied together. So you will have 6 times n plus 2 and n plus 3 again. So 5 will be multiplied by that. N plus 2 multiplied by n plus 3. And this fraction needs to be given 6 and n plus 3. And this one will need to be multiplied by 6 and n plus 2. Okay, so let's tidy up the numerator. You've got 5 times n squared plus 5n plus 6 minus 6n minus 18 minus 6n minus 12. Copy the denominator. No shortcuts, you can't just write it without denominator, you just need to be patient. 5n squared plus 25n plus 30 minus 12n minus 30. So that nicely cancelled. You've got 13n left. So last line to come. Last line. You've got 5n squared plus 13n. So actually I'm going to factorize it. So n times 5n plus 13. That's what this get factorized to. There you go. So you've got the answer to a question. So we found that the value of a is 5 and b is 13. There you go. And I believe there's part C, and I think that will be the last example leading to exercise 2a. Okay, so this is nothing new. This simply means you've got to find the sum of all the terms starting from 21st up to 30th term. So what does it mean? It means you need to find the sum of all terms from 1 to 30, and then you need to get rid of the ones that take you up to 21st, so you don't need 20 initial terms. So we are going to substitute 30 into our our final result here, which was n times 5n, so output that's Sn, plus 13 over 6 times n plus 2 times n plus 3. There you go. So the 30, you just need to show that you are substituting 30. You can evaluate it on the calculator. You know, once you've done this, you can evaluate it using the sigma key on the calculator, but this is only for checking. You still have to show that you are substituting 30 and you're substituting 20. Now, that's all you need to write down. The rest is just popping it onto the calculator and getting the result. 20 plus 3. Perfect. So you don't need to find those two separately and then combining. You could just write the answer and convert it into the decimal with 5 decimal places. There you go. So this is the minimum amount of work you need to show. There's absolutely no reason to show individual fractions that you are getting. Okay, now enjoy exercise 1A.